Right now, as you watch this video, you are moving, not just because the Earth is spinning at 1,600 kilometers per hour, not just because our planet hurtles around the sun at 108,000, not just because our entire solar system sweeps through the Milky Way at 828,000 kilometers per hour. You are moving towards something invisible, something monstrous, something that does not care whether you are a gas cloud, a star, a galaxy, or a civilization that has learned to ask questions about its own existence. Every second of every minute of every day, our galaxy, the Milky Way, 400 billion stars, billions of years of history, every supernova that ever detonated, every planet that ever formed, is being pulled inexorably toward a single point in space. A point located roughly 220 million light-years away. A point we cannot see directly. A point we named, with a mixture of scientific precision and barely concealed existential dread, the Great Attractor. The velocity of this motion is not a gentle drift. It is not a slow gravitational waltz. It is a cosmological sprint, 600 kilometers per second. 2,160,000 kilometers per hour, a number so large it should feel ridiculous and yet not large enough, because even at this speed, we are not catching up. We are passengers in a river that began flowing before our sun had ignited, and that will continue flowing long after it burns out. And here is the thing that fractured the elegant models of the 20th century. The universe, according to dominant cosmology in the 1980s, was supposed to be expanding. Edwin Hubble had shown this 60 years earlier. Galaxies were supposed to be moving away from each other uniformly, in every direction, like raisins in a rising loaf of bread. The whole elegant architecture of modern cosmology rested on this foundation. But the galaxies were not behaving the way they were supposed to. Not in our neighborhood. Across a region spanning hundreds of millions of light-years, galaxies were not simply expanding away from each other as the models predicted. They were being deflected. They were being pulled. Something with a gravitational reach extending hundreds of millions of light-years was sitting in the cosmic fabric like an iron boulder dropped into a lake, sending ripples through the motion of every galaxy in its vicinity. Something was pulling, and nothing visible could explain it. The cosmological models that had served perfectly well for decades were suddenly insufficient. And in science, incomplete can be a more unsettling condition than wrong, because incompleteness is harder to see, harder to resolve, and will allow you to feel confident right up until the moment everything stops adding up. This is the story of that gap. This is the story of what hides inside it. And this is the story of why, after nearly 4 decades of the most sophisticated astronomical detective work in human history, the answer is still, in the most meaningful sense, being written. Let us try to understand the scale of what we are talking about, not with equations, with something that might actually crack open the closed room of our intuitions. Pick up a glass of water. The water in your hand contains more molecules than there are stars in the entire observable universe. That is not a metaphor. That is physics. And yet, compared to the structures we are about to describe, an entire galaxy, a wheel of 400 billion stars, is not even a grain of sand. It is a bacterium on a bacterium on a bacterium, floating in a volume of space so vast that the human mind was genuinely not built to hold it. Our galaxy, the Milky Way, stretches about 100,000 light-years from edge to edge. If you shrunk it to the size of a dinner plate, our solar system, the Sun, all 8 planets, the Oort cloud, the entire realm of our astronomical neighborhood, would be smaller than a single atom on that plate. Our entire Orion arm, the spiral arm of the Milky Way where we live, is roughly 26,000 light-years long. Imagine a single leaf, a single autumn leaf, cut from its branch, carried by the current of a vast river. The river is the Milky Way. The river is heading toward a waterfall you cannot see because there is a fog bank in the way. The fog is not metaphorical, it is literal. We will return to that fog in a moment because it is one of the most infuriating obstacles in all of modern astronomy. Now expand your vision outward. Our galaxy belongs to the local group, roughly 54 galaxies spanning 10 million light-years. The local group belongs to the Virgo supercluster, 100 galaxy clusters spanning 110 million light-years. And the Virgo supercluster is merely a tendril of something larger still. In 2014, a team of astronomers led by R. Brent Tully revealed the full map of our cosmic address. They called it Laniakea, a Hawaiian word meaning immeasurable heaven. The name was chosen with full awareness of the irony. We had just measured what was previously considered immeasurable. Laniakea spans approximately 500 million light-years in diameter. It contains 100 million billion solar masses. It is home to the Milky Way and approximately 100,000 other galaxies, all of them moving, flowing, like tributaries of an enormous river, toward a single gravitational focal point. That focal point is the Great Attractor. And even this is not the complete picture. Beyond Laniakea, the Shapley supercluster, roughly 750 million light-years away, the most massive known structure in our cosmic neighborhood, accounts for approximately 30% of our local motion relative to the cosmic microwave background. And pushing us from the opposite direction, like a hand at our back, is a vast supervoid identified in 2017 that astronomers named the dipole repeller. It repels by its very emptiness, pushing matter outward because the overdense regions that would hold it in place simply do not exist within it. We are caught between a void that pushes and an attractor that pulls, between a nothing that expels and a something that devours. The Great Attractor's estimated mass is on the order of 10 to the power of 16 solar masses, 10 quadrillion suns. That number should cause a moment of genuine cognitive silence. Not the shallow awe of a social media caption, but the specific, vertiginous feeling that arrives when a human being glimpses the actual scale of what they live inside. A universe that was here for 9 billion years before our planet formed. A universe that will continue for trillions of years after the last star has gone dark. A universe for which our entire recorded history is less than a rounding error. Now we arrive at the fog. For most of human history, we have stared at the sky and tried to make sense of what we saw. We built observatories on mountaintops and in deserts. We launched telescopes into orbit. We learned to see in wavelengths our eyes will never perceive: radio, X-ray, infrared, gamma. We became, as a species, remarkably good at looking at things very far away. And then the Great Attractor reminded us that we are living inside the problem. Here's the fundamental embarrassment of our situation. The single most massive structure in our immediate cosmic neighborhood, the gravitational center of the supercluster we call home, the destination toward which every galaxy in our local universe is flowing, sits almost precisely behind the thickest part of our own galaxy's disk, as though the universe deliberately positioned the most important object within reach directly behind the one barrier we cannot simply see through. Astronomers call this barrier the Zone of Avoidance. The name comes from the observation that galaxy catalogs went blank in this region of the sky. Galaxies seemed to disappear. The band of the Milky Way stretched across the celestial sphere like a river of light, and on either side of it, galaxies clustered in great numbers, but within it, almost nothing. The term zone of few nebulae appeared in astronomical literature as far back as 1878. The reason is not mystical. Our galaxy's disk is full of things that block the view. stellar nurseries choked with gas and dust, molecular clouds dense enough to absorb virtually all visible light, billions of foreground stars washing out the faint smudges of distant galaxies. The plane of the Milky Way obscures roughly 20% of the entire extragalactic sky at visible wavelengths. 2/10 of everything that exists in the universe, from our vantage point, is hidden behind the walls of our own home. For decades, the Great Attractor hid almost perfectly within this zone. In the mid-1980s, 7 astronomers, David Burstein, Roger Davies, Alan Dressler, Sandra Faber, Donald Lynden Bell, Roberto Turlevich, and Gary Wegner, undertook one of the most ambitious observational campaigns in the history of modern astronomy. They would become known, informally but permanently, as the Seven Samurai. They compiled distance and velocity measurements for roughly 400 elliptical galaxies spread across the sky, using a painstaking empirical technique called the dn sigma relation to determine how far away each galaxy was. What they found, when they assembled their data in 1986 and 87, stopped the field cold. The galaxies were not moving the way they should be, not randomly, not noisily, but in a deeply suspicious, coherent, directed way. Across a region spanning hundreds of millions of light-years, galaxies were exhibiting peculiar velocities, motions over and above what the expanding universe would predict, that all pointed in the same direction, the direction of the constellations Hydra and Centaurus, the direction that infuriatingly passed directly through the zone of avoidance, like detectives reading an event from its aftermath when no one was present to witness it. The Seven Samurai inferred the existence of a massive structure they could not see. They estimated that the source of the gravitational pull lay at a distance of roughly 200 million light-years and contained a mass of approximately 10 quadrillion solar masses. They named it the Great Attractor, not because they knew precisely what it was, but because they knew with mathematical certainty that something vast was there. The Norma cluster, formerly designated Hubble 3627, sits almost exactly at the gravitational center of the Great Attractor region, approximately 220 million light-years from Earth, embedded in the Zone of Avoidance. It is one of the most massive galaxy clusters in the nearby universe, a dense knot of hundreds of galaxies in a mutual gravitational embrace, surrounded by superheated gas glowing at tens of millions of degrees, visible not in ordinary light but in X-ray wavelengths. Its peculiar velocity is essentially zero. It sits at the bottom of the gravitational well. Everything falls toward it. It has nowhere further to fall. The solution to the zone of avoidance came not in visible light, but through penetrating technologies. Radio telescopes detected hydrogen emissions from hidden galaxies despite the dust. X-ray observatories mapped the distribution of hot intracluster gas. In 2005, X-ray surveys reported that the Great Attractor might be only 1/10 the mass originally estimated, not because the galaxy motions were wrong, but because the source of those motions was more distributed across space. The Great Attractor was not a single object. It was a region, a gravitational basin, a cosmic watershed where rivers of matter converge from many directions. In the most recent years, the MeerKAT radio telescope array in South Africa began penetrating even the innermost sections of the Zone of Avoidance, the strip of sky within 3 degrees of the galactic plane, where even most radio surveys had struggled. What emerged was the Great Attractor wall, a vast sheet of galaxies stretching through the concealed sky, connecting the visible clusters on either side of the galactic plane like a hidden backbone of cosmic structure. And alongside the Great Attractor, another surprise was waiting in that fog. The Vela supercluster, an entire supercluster of galaxies rivaling the Shapley concentration and gravitational influence on our local flows, was completely unknown to science until radio surveys and peculiar velocity reconstructions revealed it in the 21st century. A recent study combining peculiar velocity data from nearly 66,000 galaxies with new MeerKAT observations suggests the Vela supercluster may even exceed the mass of Laniakea and the Great Attractor region combined, a structure of that magnitude, hidden in the fog, found only now. The question that should unsettle you is this: how many other structures of comparable size are still hiding in there? This is where science becomes, in the most honest and productive sense of the word, uncertain. The measured motion is real. The peculiar velocities of tens of thousands of galaxies, carefully measured across decades using multiple independent techniques, all point in the same direction. The data is not in question. What is in question? What has been in lively, productive scientific dispute for nearly 40 years is exactly what combination of structures and masses is generating the gravitational signal we observe. The conservative explanation is straightforward. The Great Attractor and the Shapley supercluster represent concentrations of ordinary matter, galaxies, gas, the familiar stuff of the visible universe, distributed in a region of unusually high density. No exotic physics required. Gravity does what gravity does. The Norma cluster at the center, surrounded by the Great Attractor wall, surrounded in turn by the Shapley supercluster at further distance. Together they account for the observed pull. However, and this is a critical however, the accounting never quite closes cleanly. Even the Great Attractor plus the Shapley supercluster leaves residuals that models struggle to explain with full precision. The universe keeps offering more signal than the visible matter alone can account for. The next layer of explanation involves dark matter. We know with the same degree of certainty, we know that atoms exist, that approximately 85% of the matter in the universe is not made of atoms at all. It does not emit light, does not absorb light, does not interact with the electromagnetic force in any way our instruments can directly detect. We call it dark matter, a name that successfully conveys our ignorance while sounding far more authoritative than it deserves to. In the context of the Great Attractor, dark matter is not a speculative addition. It is a structural requirement. Galaxy clusters and filaments sit inside dark matter halos far larger than the visible galaxies themselves. When we estimate the mass of the Great Attractor region, dark matter must already be factored in, and the remaining residuals suggest that either the distribution is not yet fully mapped, or the attracting structures extend further than current surveys have confirmed. Then there is the connection to the deepest unresolved problem in modern cosmology, the Hubble tension. The Hubble constant describes how fast the universe is expanding. Astronomers measuring it from the cosmic microwave background, from the afterglow of the Big Bang, imprinted on the sky 13.8 billion years ago, get approximately 67 kilometers per second per megaparsec. Astronomers measuring it from distance indicators in the nearby universe consistently get closer to 73. This discrepancy, the Hubble tension, is one of the most serious unsolved problems in physics today. Why does this matter for the Great Attractor? If our local region of the universe is embedded within a vast, subtle underdensity relative to the cosmic average, a proposed structure called the KBC void, roughly 2 billion light-years across, our local measurements of cosmic expansion would be systematically biased toward higher values than the global measurement. We would be living inside a bubble of relative emptiness, and from inside that bubble, the universe would appear to be expanding slightly faster than it actually is. The motion of our galaxy toward the Great Attractor at 600 kilometers per second might not be just a local gravitational curiosity. It might be a clue about the global structure of the entire cosmos. And then there is dark flow. perhaps the most radical idea still on the table. In 2008, researchers led by Alexander Kashlinsky announced they had detected a coherent bulk flow of galaxy clusters extending not hundreds of millions but billions of light-years in a single direction. If confirmed, dark flow would imply the existence of gravitational attractors so distant they lie beyond our cosmic horizon. Structures from before the epoch of last scattering, or from regions of space our light cones will never overlap. Structures from outside our observable universe, pulling at the matter within it across a boundary we can never cross or see beyond. The scientific community remains intensely divided on dark flow. Multiple subsequent analyses have both supported and contradicted the original claim, but consider what a verdict in its favor would mean. The Great Attractor, already the largest structure we can directly observe influencing our motion, would itself be a tributary of a current whose source lies beyond the edge of everything we can ever see. The river we are riding would be a branch of a river we cannot map. The train would be moving toward a destination that is structurally, permanently, irreversibly invisible to us. The honest answer, given by any careful scientist working in this field today, is that we do not yet have a complete accounting of the mass driving our peculiar velocity. We know the direction. We have a partial inventory of the sources, but the precision of our understanding lags behind the precision of our measurements, and the gap between those two things is where the most interesting science is happening right now. Imagine you are on a train. Not a modern train with GPS and a destination board. An older train. A train moving through fog so thick you cannot see the tracks. A train that has been moving since before the first passenger arrived, since before anyone thought to ask where it was going. You can feel the motion in the vibration of the windows, in the drift of your coffee in its cup. You know the train is moving. You have calculated the direction, approximately Salki, through ingenious indirect methods, by watching how other trains seem to move relative to yours, by measuring the Doppler shift of their headlights through the fog, by painstakingly mapping the gravitational landscape through shadows and distortions that the fog cannot block. You know you are heading somewhere. You have a partial sketch of the destination, but you do not know what waits at the end of the line. You do not know whether the train will arrive or slow or be pulled by forces that your maps have not yet captured. And you know, with quiet certainty, that the journey was underway for billions of years before you were born and will continue for billions of years after the last passenger has disembarked. This is not a metaphor designed to manufacture existential anxiety. It is an accurate description of the human condition in relation to the Great Attractor. The Milky Way, the galaxy that contains our sun, our solar system, every human being who has ever lived, every piece of music ever written, every war ever fought, every prayer ever offered, is moving toward the gravitational center of Laniakea at 600 kilometers per second. It has been doing so for billions of years. It will continue doing so for billions more, until dark energy, the mysterious pressure in empty space that is accelerating the expansion of the cosmos, eventually stretches the cosmic fabric faster than gravity can pull it together. Until the rivers of galaxies flowing toward the Great Attractor finally slow, and the current that has carried us since before the birth of our sun becomes too weak to matter. But here is what I want you to sit with. We are the only part of this process that knows it is happening. The galaxies have no awareness of their motion. The dark matter halos have no consciousness of the structures they create. The Zone of Avoidance does not know it is hiding anything. The Great Attractor itself, that vast, fog-shrouded, inexorable gravitational engine 220 million light-years away, is not pulling us intentionally. It is not malevolent. It is not benevolent. It is not anything, in any sense, that matters to those of us being pulled. It is mass, and mass warps space, and warped space directs the motion of everything within it, from photons to galaxy clusters, with a mechanical indifference so complete it almost feels like cruelty. And yet we stand here, brief arrangements of atoms that briefly learn to think, and we ask, what is out there? What is pulling us? How large is the universe? Where are we going? Those questions do not arise from any mechanical process. They arise from consciousness, which is itself one of the universe's most inexplicable products. A universe that operated in silence and darkness for 13.8 billion years has, in the last few 100,000 years, produced at least one example of matter that became aware of itself, mapped its own motion through the cosmos, inferred the existence of a 200 million light-year, distant gravitational attractor from the anomalous velocities of 400 elliptical galaxies, and sat down to make a video about it. Think about what the 7 samurai actually did. 7 human beings, born on a planet smaller than most planetary atmospheres, in a solar system that is a comma in the history of the Milky Way. They pointed telescopes at the sky, collected light that had traveled for hundreds of millions of years, compared distances to velocities, found a pattern in the deviations, and inferred the existence of a structure so massive that no previous generation of astronomers had known it was there. They did this with their minds, their mathematics, and their willingness to follow data wherever it led, even when it led into the fog. That is one of the most remarkable things that has ever happened in the universe. The Great Attractor did not reveal itself willingly. It hid behind our own galaxy. It forced us to build instruments that could pierce the dust and gas and starlight of the Zone of Avoidance. It forced us to develop indirect methods requiring decades of collective intellectual effort across dozens of institutions. Every new wavelength we learned to detect, every new survey we completed, revealed a little more of the hidden structure. The MeerKAT telescope, pointing its dishes at the densest part of the galactic plane, found galaxies that had been there for billions of years, invisible to every instrument we had previously pointed in that direction. We are a civilization in the early stages of learning to read a library written in languages our senses cannot naturally perceive. We are beings who have only just invented writing, sitting in a library that contains every book ever made, holding a single candle, able to read only the titles on the nearest shelves. The Great Attractor is a title on a shelf partially visible through a gap, written in a language we have only partially deciphered. And beyond it, in the direction of the Shapley supercluster, the dipole repeller, the newly revealed Vela supercluster, the possible dark flow that pulls everything toward a horizon we can never reach, there are more shelves than we can count, in more languages than we have learned, containing information about the universe that we have not yet thought to ask for. The universe is not obligated to be comprehensible. The cosmos does not owe us clarity. The Great Attractor did not arrange itself conveniently in clear view. It happened to form almost precisely behind the thickest curtain of dust and stars in our sky, as if to remind us that the most important things are often hidden, and that seeing requires more than eyes. It requires instruments, mathematics, the refusal to accept that because something cannot be seen, it does not exist. The Zone of Avoidance is not just an observational obstacle, it is a philosophical statement. The universe conceals its deepest structures behind the very fabric of our own home. To see the forces that govern us, we must first find a way to see through ourselves. Every map we make is drawn from inside the thing being mapped. Every model of the universe is constructed by beings who are part of the universe, shaped by its history, located within its structure, subject to its forces, moving through it at speeds they cannot feel. There is no outside view. There is no position of perfect objectivity from which the whole can be seen at once. We are the universe measuring itself. We are rivers wondering where they flow. Expansion will eventually win. In hundreds of billions of years, dark energy will pull the distant galaxy clusters beyond the reach of the Great Attractor's gravity. The rivers will slow. The structures converging today will be torn apart by the relentless stretching of space. The Great Attractor will cease to be an attractor at all, an island surrounded by expanding void, its influence shrinking even as its mass remains. The train will slow, the tracks will end, the fog will thin, and there will be nothing at the destination except the quiet of a cosmos that has expanded beyond all connection. But that is not yet, not for hundreds of billions of years. For now, the river runs. For now, the Milky Way races toward the Great Attractor at 600 kilometers per second. For now, we are passengers on a train moving through fog, and for now, we are also the ones learning to read the landscape through that fog. We are building instruments that see in wavelengths the fog cannot block. We gave a name, MeerKAT, immeasurable heaven, to the structure we live inside, because naming is how humans begin to understand, and understanding is the only light we have ever been able to generate entirely on our own. The Great Attractor does not know we named it. The universe does not care that we mapped it, but we do. And that caring, that persistent, irrational, profoundly human insistence on asking where we are going and why, on finding meaning in the patterns of light that have traveled 200 million years to reach our instruments, on refusing to accept the fog as final, is perhaps the most extraordinary thing the universe has ever produced. Somewhere, 220 million light-years away, in a region we are only beginning to map, the river bends and the current deepens, and the universe continues its long, silent work, unobserved by anything except the brief, strange, luminous fact of us. We are passengers on a train hurtling through fog toward a destination we cannot see, but we are also, remarkably, improbably, perhaps uniquely in all the cosmos, the ones who figured out that the train was moving at all.